All right, ladies and gentlemen, I've got a request going out for Hannah Combo right here. Hannah, this one's for you. So when you're going to put this into a picture, you got to remember that it's got to make a rectangle. The rectangle's got to have all these things in the middle of it. The middle of it has to be 4 X's in the middle, 6 in the middle. They have to make a rectangle, so 4 has to be 4 by 1 or 2 by 2. 6 has to be 6 by 1 or 3 by 2. What's common? 2. So you have to make them in groups of 2s, and then you fill in the rectangle. Okay? Always remember, you take your greatest common factor, it goes out here, and then you divide each one by that greatest common factor. Is it always the only factoring you do? No. Is it always the first factoring you check for? Yes. All right. So here's another one right here. Common to that is 8. So we're going to divide everything by 8. How many C's? 1 C. How many D's? None. Cannot be 2 C's because there's only 1 C here. So the answer is 8C, and then we put our answers in. 3C squared minus 2D squared plus 7CD to the 4th. Common factor here? 5. Any letters? No. So 5 comes out. Now remember, this is an error that a lot of you are going to make when you are rushing through your provincial because you feel you're going to get extra points for finishing first. 5 divided by 5. You have always been taught that tonsils, which you guys seem to think makes it disappear. It does not. It is 1 minus 2z minus 3z squared. Now, would you attempt to factor that if we were one lesson further? Yes, you would, because that is a trinomial, and it is possibly factorable. Okay? I have not taught you how to factor anything with a coefficient that is with the z square yet, but guess what today's lesson is? He pointed at the screen and nodded with that face that he has when he is doing things like that. Okay? This one, 3g plus 2. And this one, what is it? 4d. 2 plus 3d. Cool in the gang? 1 mark for everything. Okay, this one. This bothers me because a lot of kids say they can't do it because there's no numbers there, which makes no sense to me at all. What is common to both of these? Pi is in both and r is in both. So you have a greatest common factor, don't you? The greatest common factor goes on the outside, and in the middle we leave r plus s. Done. For 1 mark. Now find the surface area if the radius is 5 and the slant height is 2. Radius is what? R. Slant height 2 is S. And then you just fill it in. Pi times 5 times 5 plus 2, which is, of course, 35 pi. With no calculator at all. Yeah? This, like we did in the first unit, bit of a pain in the butt. Hard to do in your head. This, not so much. And 4 expands. These will take 2 seconds. Why will these all take 2 seconds? Because they're all the shortcut. X squared, except for that one. X squared plus 2x minus 10. 6x squared plus 8xy. 15. Yeah. 15. 6x squared minus 8xy. X squared plus 6x plus 8 and x squared minus 6x plus 8. And we're done. 1 mark for everything. 4, 5, 6. 6 is 12. 13 for that. I'll get that later. And this, what did I say about this one? This page was just homework, yeah? Okay. Did people want some more time with it? Okay. We'll do the right answers to that tomorrow. Because that, excuse me, that is all stuff you already know how to do. It just, there's some tricky, different looking stuff in there. Okay, but it's all stuff you actually know how to do. Factoring practice, we'll come back to that later. I just want to check something. Yeah. I'm gonna do, what is your guys' next thing in your notes? Is it difference of squares with bubbles?
Yep.
Excellent. Okay. This is going to be, this is weird because it seems like it should be very easy to me. And yet, I have great difficulty with my students seem to have some issues with it. So, I just want to check your outline here. Is difference of squares next? No. We're going to skip up to difference of squares. Yeah. Do I want to do it that way? Do I want to do difference of squares now? Oh, yes, I do. Oh, it's a gamble, but I think we're going to do fine. When I say go to your textbook today, do not all go to your textbook today. I want to make sure. I gotta have a look at it. Okay? Okay. Difference of squares. Where have you gone? This font is called Cocktail Bubbly, and this font is I don't remember. All right. Guys, difference of squares, you've already actually done it, written out in the long way. What do I mean by long way? You will see in a second. Call your attention back to your last bit of notes. And on that last bit of notes, these two right here. What did you notice about these two trinomials? X squared and 625 is a square, isn't it? X squared and 9 is a square, isn't it? And there was no linear term, right? I wrote that linear term in so you guys could see that you would know how to factor them, right? Multiply to negative 9, add to 0, right? But really, would we ever write that in a million, gajillion, trillion years? No, because 0 we don't write, right? 0 is a placeholder. Everybody cool? Okay, so all of you know how to factor these the trinomial way, right? But what would this expression really look like? It would be x squared minus 625, wouldn't it? And this guy would really be x squared minus 9, wouldn't it? Right? And when we factored it, you all noticed something as well, I hope. What did you notice? One's positive, one's negative, and what are they? They're the square root of the constant term, correct? And the first one, x, was the square root of the quadratic term. Everybody cool? Now, if that happened twice on this page, what is your bet that it continues to happen? A lot. It should be everything you've got, right? So just to remind you of that, let's expand this properly. So we're actually going to write it out. We're not going to do a little shortcut, okay? So if I was going to expand this properly, I would have to FOIL it, yes? And I would get x squared minus 4x. Then I would go to a new line, plus 4x minus 16, yes? And then I would collect my like terms, and I would get x squared plus 0x minus 16, which of course I would never write, and I would get x squared minus 16. Now I'm going to look at that. Ow, sore knee. Describe to me what that is. Describe that in words. What would you say that is? It's a binomial. Good. I certainly hope you could describe things better than that. Who's that beside you? Describe her. She's a girl. There's more to Supreet than she's a girl. Yes? So there's more to this than is a binomial. So keep talking. What else do you see here? Kobe. There's a letter and a number. Excellent. So we have a variable and a number. Good. What else? Parveen. The 16 is negative. Excellent. Supreet. A constant and a quadratic term. Excellent. No linear term. Good. What else? What do you notice about the... Oh, Parveen. 16 is a square. What else? X is a square, isn't it? Right? So what I have here is I have a squared term, a square term, minus another square term. Correct? Right? What's the title of this section? Difference of squares. Difference is what math? Subtraction. Square minus a square. Everybody cool? Now you guys are smart kids. This is the expanded form, yes? This is the factored form, yes? What's the pattern? If I have a squared, anything squared, minus b squared, what does it look like factored? Pardon? Say it. A plus b. You're close. A minus b. It's not a and b, because it's not x and 16. What is it? Still close, because that's the quadratic. So if I said if it's a squared, then this is a. What must I do to a squared to get it to be a? Is what I'm trying to get at. Square root, right? This is the square root of the first term, square root of the second term. Square root of the first term, square root of the second term. Is everybody with me? And that's it. Now, as Michaela found out when she was doing the practice sheet, looks can make this deceiving, yes? But the rules still apply, okay? Now this first one is actually incredibly difficult because everybody messes it up. So I'm starting with it, okay? Now, if this, do not write this down, were x squared minus 1, could you factor that? Because it's a difference of squares, isn't it? Okay, what's the square root of the first term? X plus what's the square root of the second term? 1. And then we do x minus 1, correct? Everyone agrees? You see how that works, because we did that 2 days ago, yeah? With the 0 in the linear term. Everyone's cool, right? Okay, so now you need to apply your exponent laws to this problem. Is x to the 16th a perfect square? It is indeed, yes. What is its square root? X to the 8th. Absolutely correct. Because x to the 8 times x to the 8, we add the exponents to get x to the 16. Everybody cool? So this guy, we see perfect square minus perfect square. Yep, I can run it through square root of the first one, x to the 8th, plus square root of the second one, 1. Square root of the first one, x to the 8th, minus square root of the second one. Now here's the problem. 50% of you will stop there thinking, yeah, I got it. Why can you not? Because doesn't 8 break down? So that's the first mistake. Mistake 1. People forget to continue. That's mistake 1. Mistake number 2, they forget what they already factored. What do I mean by that? When you continue with this work, can you forget x8 plus 1? No, some of you will. So, we keep x8 plus 1, which we can't factor. Why? Why is there no sum of squares? Don't write this down. Why is there no sum of squares? How would you try to factor that if I wrote it out? X squared plus 0x plus 4. How would you try to factor that? What would you have to multiply to? 4. And what would you have to add to? 0. See why it doesn't work? Because to get to multiply to 4, it's got to be 2 and 2, right? But to add to 0, one of them would have to be negative, wouldn't it? And that would give me a negative 4 here. I can't do x plus 2, x plus 2, because that would be x squared plus 4x plus 4, wouldn't it? And I can't do x minus 2, because that would be x squared minus 4x plus 4. And you can't make that linear term drop out. Does everybody see? There is no sum of squares. It is only a difference. Okay? That's why. If you want to write it down, go ahead. But you shouldn't need to, because you know how to factor already. So this guy can't be touched. But what do I got to do to this guy? What do we do to 16 to break it down? Divide it by 2. So what do I do to 8? To get x4 plus what? Square root of the first one, square root of the second one. 1. And then x4 minus 1. Am I done? Why? Because x4. Can I forget about 8 and 4? No. X to the 8th plus 1, x to the 4th plus 1. Now what? Same thing again. So what's the square root of the first term? X squared plus, what's the square root of the second term? 1. Then I write it again. Am I done? No, why, Supreet? squared has a square root. Oh, good gravy. They love this on the provincial. And you should be saying to yourself, how do they do a multiple choice question on the provincial like this? I'll show you. Square root of x squared is x plus 1, x minus 1. And that's where we would stop. Is everybody cool? Now, how do they do this as a provincial question? They give you this, and they say, after factoring, how many factors does this have? And what's the answer? 5. You understand? They do that all the time. Everybody cool? Okay. Now, please notice that I am showing you, normally I start with stuff that follows the pattern, then I build up, yeah? I'm not doing that this time because the pattern is so easy. Square the first one, square the second one. Square root the first one, square root the second one. Everybody can do that in their head in 2 seconds, right? The reason this gets difficult is when the looks change. So let's have a look at number 2. Does it fit the bill? Is this first term squared? Yep, it's the second term a perfect square. So can we do our square root plus square root minus thing? Yeah. So all I do is I do the square root of the first one. What is the square root of the first one? xy. Plus, what's the square root of the second one? 15. And then what do I do? Same thing. See how easy it is? Everybody cool? Okay, let's look at the next one. Can I handle that? What is it? Z4 plus 12 and Z4 minus 12. Can we go any further?
Yes.
Why? Yeah, Z4 is definitely a square. Is 12? No. So can I go any further? No. So this is another mistake you guys make. You don't know when to stop. Right? Because you're not actually thinking about what you're doing. You're thinking about whether or not it fits your patterns. Yes? So here, Z4 is a perfect square. But 12 isn't. So we stop. Cool? Cool? All right. Now look at 4. It looks ugly. But is it a perfect square? Yes. Because 4 has a square root and x to the 6th has a square root, doesn't it? Is 25y squared a square root, or a perfect square? Yes, because 5 has a square root and y squared has a square root. Is it subtraction? So can I run it through? What is the square root of the first one? 2x cubed. Plus, what is the square root of the second one? 5y. And then what do I do? 2x cubed minus 5y. Is everybody okay? Yes? Everyone is good? Okay. Now notice you should have a little bit of white space at the bottom of your paper, yeah? Okay, a little bit. All right. So there's a couple of ways that this can get in your head a bit. Okay? Let me give you one. 32x cubed minus 50 y No. Minus 50x. Okay, so this is, what letter are we up to? Or number. This would be number 5. This is one of the things that could screw you up. Could you factor that? What's the first type of factoring he always says to try? I don't remember. GCF. Could you GCF that? What? Eight goes into 50? Nope. 2 and x. So let's take out 2x. Everybody cool? So we write 2x, and what's left in there? 16x squared minus 25. Now look at it. Can you factor that? Do you do anything with 2x? Nope. But what do you get here? Is that a perfect square? Is that a perfect square? So can you do square root? Great. What's the square root of 16x squared? 4x. Square root of 25? 5. And then? Minus 5. Cool? That's the first thing that's going to mess with your guys' heads. Everybody okay?
So even if you're asking for if you're specifically asking to do the GCF one, and you can square at the end like that, you still do it, no matter what?
Always factor completely. Never stop factoring until you can factor no more. Okay? Now I'm going to do the next one that'll mess you guys up. I hope you have a bit of room. Everybody ready? Okay, I don't want to screw this up. Give me a second to think about it. Okay. Could you factor that? Is this a perfect square? Yeah, because it's squared, Michaela. Right? So if I were to write this out, what would it be? It would be x plus 7 times x plus 7, right? Which is the same as 4 times 4 getting 16, yeah? So what's the square root of x plus 7 squared? X plus 7. And what's the square root of x minus 4 squared? X minus 4. Everybody got it? I'm going to give you guys a little tip. Check this out. A equals x plus 7. B equals x minus 4. Now, can I rewrite that? It would be a squared minus b squared, wouldn't it? And that you can do in your sleep, can't you? What's the square root of a? What's the square root of a squared? A plus b times a minus b, right? Now, look how easy that is. What's a? X plus 7 plus b, x minus 4, right? So that, what's x plus x? X plus x, 2x, and what's 7 minus 4? 3. And that's the first half, yes? Everybody cool? And what would the second half have been? A minus b, which is x plus 7 minus x minus 4, yeah? What's x minus x? 0. And what's 7 minus minus 4? 7 minus minus 4, which is same as 7 plus 4, which is 11. That's how you factor those guys. Do you have to do this thing with the a and the b? I find it easier. But some kids don't. It's up to you. That's about the hardest difference of squares question I could give you. Actually, I lie. Do you guys want to see the hardest one you could possibly get?
Yes.
I'm going to show it to you anyway. Supri.
Don't you go further to 96 and don't you expand 11?
No. Because you would never expand. We're trying to factor. Okay, we want it factored. If you distribute that 11 in there, then you have 22 and 33, which you wouldn't want because you can factor it out. Factor, factor, factor. Everybody cool? Okay, everybody look at this, because this is kind of badass. X squared plus 7x minus 18 squared minus x squared minus 4x minus 12 all squared. That's about the hardest difference of squares question I could give you. How would you approach that? Think about everything you know about factoring. How would you approach that? Because you actually have all the tools you need to do that question. Parveen, what would you do?
I'm not sure if it's right or not, but it would be like some time that will
So you would factor just this trinomial. Okay. Okay. What would you do, James? Same thing. What would you do?
I find GCF at
The second trinomial has no GCF. There's a 4 there and 4 works there, but that doesn't work here. Is it a difference of squares? So can you make that A and that B? You could, right? Which would mean I would need the square root of that and the square root of that, right? So what is the square root of x squared plus 7x minus 18 squared? X squared plus 7x minus 18, isn't it? So it would be x squared plus 7x minus 18 plus, what's the square root of b? X squared minus 4x minus 12. And all of that would multiply by what? The same thing, but with what? A minus between them. So what would you do here? Guys, you're in honors class. What would you do here? You have a trinomial plus a trinomial. Guys, you're in honors class. You've done grade 9. Collect like terms. Thank you. X squared plus x squared is what? 2x squared. 7x plus negative 4x plus 3x. Negative 18 plus negative 12, negative 30. Cool? That would multiply by this side. What's x squared minus x squared? Gone. 7 minus minus 4. 11x. 18 minus minus 12. Negative 18 minus minus 12. Negative 6. Now, look at that. Do you think there's some place there you could factor? I'm not saying you're able to factor it yet, but is there something there that looks like it might factor?
2x squared plus 3x.
This guy might factor. Again, I haven't taught you how to factor that guy yet. There's a reason I haven't taught you how to factor that guy yet, because I want you guys seeing things that look suspect. Do you understand what I'm saying? I want you guys to see that and say, oh, maybe that needs to factor, but I don't know how to do it yet. Do you understand? Because then your eyes will be caught by stuff that you need to factor. Because later on, when you have all the tools on a really long question, there's a chance you're going to forget something if you have all the tools all at once. Do you understand? So this is as far as we can go now. Does everybody see how to do it? Now, could we have done Parveen and James's thing? Could we have factored this? Yeah, we could have. To get what? I would have had to multiply to negative 18 and add to 7. What is it? Positive 9, negative 2, yeah? So this guy is x plus 9, x minus 2. And all of that is squared, isn't it? Right? Minus, and then I would have factored this guy. Multiply to negative 12 and add to negative 4. What is it? X plus 2, x minus 6. Yes? And all that would be squared. Everybody still cool? Now, can I square root that? It's going to be x plus 9, x minus 2, plus this side, x plus 2, x minus 6. And then I'm going to do the same thing over here with what in the middle? Minus x plus 2, x minus 6. Am I done there? Okay, I would have to collect like terms, which I could only do by expanding. Do you understand what I'm saying? And then we're still back and stuck here, because you guys don't know how to do that yet. So, would your way have worked, Parveen and James? Yes, you would have just needed to do an extra problem, or an extra expansion. But you would still get to this final point. Okay? I'm just seeing if that will factor. This wouldn't have factored anyway, so we're done. Everybody cool? That's about the hardest thing I can give you. Everybody okay? All right. So,